answers from Demel. I'm waiting for some answers. Amani, what's going to happen to the Kool-Aid? Ooh, thank you for that answer. I got Liam who answered me. What else? Now I have a question. Jemiah and Jabril left Kool-Aid, but they used different concentrations. So let's see if Jemiah and Jabril's Kool-Aid are going to freeze, like a lot of people are saying in the chat, how we expect, okay? All right, so here we go. I'm going to let you look at this picture for 1 minute and tell me, what do you see, about Joel's Kool-Aid, which is not really Kool-Aid, and why is it Kool-Aid? What do you see from this picture? What do you see from this picture? Just tell me what you're looking at. The differences between the red and the white. What are the differences that you see in these pictures? I'm waiting for some answers in the chat. What do you see between the pictures, the left, Jabril's, and Joel's on the right? All right, Jalen, I love that. He noted a really key point right there, freezing point. That is a really good vocabulary word to know, freezing point. Go ahead, Jalen. What about other differences? What other things do you see? So we got different numbers and freezing points. What do you see about the solution or the mixture themselves? Oh, you can't see the picture on the screen? Hold on. Let's bring this up. Here we go. I showed you now. It should be on your Nearpod, so anyone who is connected to the Nearpod should be able to see it, but we will also have it here so you can see. So Joel, Liam said his is just water. Liam, that's a really good point. Can you unmute yourself and can you tell me, why do you think that his is just water? Go ahead.
His has no Kool-Aid particles in it.
Oh my God, Liam, that was perfectly said. Absolutely. If you notice in Joel's solution here, which is just water, it's not actually Kool-Aid. It's just water. And the water particles are stuck together, are bonded, which means that it's frozen. But Jabril's Kool-Aid didn't freeze. Jabril's Kool-Aid did not freeze. So Jalen, can you unmute yourself? You brought an interesting point here. Jalen said Jabril is half frozen. So Jalen, can you unmute yourself and can you tell me, why did you say that?
I said that because the freezing point is one for Jabril's is 18 and Joel is 30.
Okay.
Oh.
Okay, so he went mathematically here. He's looking at mathematically, we have Joel's froze at 32. So if the freezing point of Jabril's is half, then it must be half frozen. You know what? That's actually a very brilliant point. That is it's something good to observe. But can you tell me particle-wise, why do you think that Joel's water froze, but Jabril's didn't? What's going on with the particles, Jalen?
I say what you said because you said the particles are together and Jabril's is like the particles is not like Joel's, so it will make more sense for Joel's to freeze.
Okay, so what do you see? What's the difference in particles between Joel's and Jabril? So Joel, what kind of particles do we have? And Jabril, what kind of particles do we have?
I don't even know.
Look at the letters. Look at those letters. What kind of letters do you see in Joel's? And what kind of letters do you see? Remember, we have water and Kool-Aid. Those are the two mixtures that we have, or the two.
Jabril's have K and W, and Joel's have W.
Exactly. So what can you guess then? If Joel's has just W and it freezes, and Jabril has K and W and it didn't freeze, what do you think is going on with the K and W's?
I just don't even know.
That's okay. That's okay. We want to work through this, right? So we're doing it together. Does anyone have a good idea? What do you think is going on with the particles that doesn't allow that Kool-Aid to freeze? I got Demel who has an idea. Go ahead, Demel.
I think it's
Because particles are spread it out.
Okay, so the water particles are spread out more because the Kool-Aid is in between them, right, Demel? Absolutely, that is a perfect answer. So that is exactly what I was looking for. The water particles in Joelle's water are so close together that it's very easy for them to freeze. So they freeze at 32 degrees, which is not that cold. Okay, so that's how when snow falls, it's usually around 32 degrees. But Jabril, he has Kool-Aid in between his water particles, which means it's going to be harder for those water particles to stick together. And so they need to get closer to it at colder temperatures for them to freeze, okay? So let's say that there was a cloud full of Kool-Aid and a cloud full of water. It would have to be a lot colder for that cloud full of Kool-Aid to make snow, okay? Does everyone make sense? Does that make sense? Amani, can you unmute yourself and can you tell me? Which one freezes more? Which one out of water and Kool-Aid? Which one is going to freeze? Which one needs a colder temperature, I'm sorry, to freeze? Amani, this is your party and you're not even paying attention. This is wild. You have the Kool-Aid mixture that has the Kool-Aid and the water particles, and you have just the water particles on the right. From what you can see, what we've been talking about, which one is going to freeze at a colder temperature? Water or Kool-Aid? Look at the numbers, freezing point 18 and freezing point 32. Which one is the lower number? Amani? There we go, Amani. Let's pay attention the whole time in class so that we can get these answers faster. Exactly, the Kool-Aid is going to take colder temperatures to freeze. So here we go, we have another representation of that same information. Now, can someone tell me, on the left, I know it's a lot, so please walk through this so that we can make sure we know how to read this, okay? So on the left, temperature that it freezes, okay? Temperature that it freezes, the Kool-Aid. We have over here, temperature and concentration, okay? So the colder, at 32 degrees, 0 concentration, water freezes or solution freezes. The more concentrated it gets as you go down, the colder the temperature gets. Okay, so here you go, you see more concentrated on the right, the colder it needs to be to freeze. All right, everyone? All right, so here we go, we have a question. The more concentrated a solution is, the colder it needs to be to freeze. True or false? Make sure you answer that question, true or false. Go ahead and get started.
Great. Let me see who's already answered our question. Please make sure that you click on submit. We're practicing clicking on submit.